Okay, this is the first video for the Chapter 3 review. I'm hoping to get through about the first 9 or 10 questions on the review. The first one is factor the trinomial. When we factor trinomials, we are looking for the two numbers that multiply to give us the C term 24. Those same numbers need to add up to the middle -10. And it can sometimes be very difficult to find this pair of numbers. So think about ways to get 24. We've got 1 times 24. We've got 2 times 12. We've got 3 times, is that 8? Sometimes my multiplication facts get to me because my mental math is not super strong. We got 4 times 6. 5 doesn't work. 6 times 4. We've got them all. Then look at those numbers and think which ones could get me to -10. And there's two possibilities here. There's 2 and 12, and there's 4 and 6. 2 and 12 would work if we were trying to multiply to get -24. But since we're trying to get +24, both numbers need to be positive or both of them need to be negative. So if these were both positive or both negative, it would be -14. We don't want that. But if we've got -4 and -6, that adds up to -10. -4 times -6 is +24. So our factored form is x minus 4, x minus 6. And this is set up so that it does not matter which order you do this. So you do need to use Chrome, not Microsoft Edge when you're doing this. But you grab the x minus 4 and drag it in. Grab the x minus 6 and drop that in. So it's a drag and drop problem. This next one is it is a greatest common factor factoring problem. So what do these two terms have in common? 14 and 7, we can divide both of those by 7. X to the 4th, x squared, we can divide both of those by x squared. So 14 divided by 7 is 2. X to the 4th, take x squared out, you've got x squared left over. If you remultiplied these out, x times 7x squared times 2x squared is 14x to the 4th. Then -7 divided by 7 is -1. X squared divided by x squared is 1. So we have 2x squared minus 1. Which is this one right here. Honestly, once you get this part, you probably have enough information that you could pick out the correct answer. This time when we factor the trinomial, there's a number in front. 2x squared plus 3x minus 14. When there is a number in front, we need to multiply those two numbers together. So we're actually looking for two numbers that multiply to give us -28. Those same numbers need to add up to 3. So ways to get 28. We got 1 times 28. We've got 2 times 14. We have, can you do 28 divided by 3? That's decimal. 28 divided by 4, 4 and 7. I think that's it. 4 and 7 work if it's a -4 and a +7. Now, we can't just do x minus 4, x plus 7, because x times x is x squared, not 2x squared. So we can do this by grouping or by guess and check. I'm going to do this first by guess and check, and then I'll do by grouping. So by guess and check, I know that the first terms multiplied together are going to give me 2x squared. So that's going to be 2x and x. 2x times, I feel like I need to sneeze. I think I paused it before I sneezed, but you might hear part of my sneeze in that video. 2x times something is going to give us one of these numbers times x. So 2x times something is probably not going to give us 7x. It's probably going to give us -4x. So I know that that needs to be a -2, which means x times something has to give me 7x, so that's going to be a +7. So my factored form is 2x plus 7 times x minus 2. Now, if you prefer factor by grouping, you would do 2x squared you'd take this middle term 3x and split it up using these numbers. So minus 4x plus 7x, and then the plus 14 from the end of that problem. Split this into two groups. This first group, they have 2x in common. That would leave us with x minus 2. 7x and 14 have 7 in common. X minus 2. What did I do wrong? Oh, hey, that's a minus 14, isn't it? There we go. So then the factored form is 2x plus 7, x minus 2. So whether you do guess and check or factor by grouping, you should end up with 2x plus 7 times x minus 2. Solve the equation. I see x squared and x. Anytime you see x squared and x, you want to check to see if you can factor first. Some of these you might have to use quadratic formula, but here's a really huge hint. Do you see how I didn't give you the quadratic formula on this problem? If you need the quadratic formula, I will likely give you the quadratic formula. So this one, I'm guessing we don't need it. I do need to get one side equal to 0. So I'm going to subtract 10 on both sides to get one side equal to 0. Now I'm going to try to factor. Two numbers that multiply to give me negative 10 and add up to 3. I'm guessing that's going to be 2 and 5. We need to have negative 2 and 5. So x minus 2, x plus 5 equals 0. If x minus 2 has to equal 0, then x would be positive 2, because 2 minus 2 would be 0. If x plus 5 had to equal 0, x would have to equal negative 5, because negative 5 plus 5 would be 0. So in these boxes, you're going to type it in using your keyboard. There's no math keypad, it's just your own normal keyboard. X is 2. And x is negative 5. Don't put any spaces between the minus and the number, just minus sign, 5, call it good. And it's set so that even if you put negative 5 here and 2 here, it will still count that as correct. Solve the equation. This time I see parentheses squared, so I want to get those parentheses entirely by themselves so that I can square root to solve this problem. I'm going to start by adding 8 on both sides. And then I'm going to divide by 2. So I have x plus 6 squared equals 49. To undo a square, you use a square root. And when you put a square root into a problem, you have to put a plus minus in front of it. So x plus 6 is going to be the positive or negative square root of 49. The square root of 49 is 7. Subtract 6 on both sides. We have x equals negative 6 plus or minus 7. Do the problem once using the plus sign. If we use the plus sign, we do negative 6 plus 7. That answer is 1. When we use the minus sign, negative 6 minus 7 is negative 13. So our answers are 1 and negative 13. It doesn't matter which blank you use. You can put negative 13 in the top one and 1 in the bottom one. It will still count them both as correct. Here's another one where we need to solve using square root. So same exact type of problem. Start by getting them by itself, the parentheses by themselves. We need to subtract 7 on both sides. Negative 18 minus 7 is negative 25. Square root both sides. Don't forget your plus minus. The plus minus is what ends up giving us the two separate answers. X minus 1 equals positive or negative. What is the square root of negative 25? The square root of negative 25 is the square root of negative 1 times the square root of 25. The square root of 25 is 5. The square root of negative 1 is I. So it's plus or minus 5i. Add 1 on both sides. X equals 1 plus or minus 5i. So our two answers are, don't need you, 1 plus 5i. The other one is 1 minus 5i. No spaces, nothing fancy. I know it doesn't look like math type, but 1 plus 5i, 1 minus 5i, no crazy spaces. Just get that typed in there. Simplify the radical. 4 times the square root of 54. Okay, keep that 4 for later. The square root of 54, I like to start with half of 54. Half of 54 is 27. So then the perfect squares, if I were you, I would make sure you have in your notes like a list of perfect squares written down. So 25 is the closest perfect square. So I would try 54 divided by 25. That's a decimal. 54 divided by the next smallest one is 16. That's a decimal. 54 divided by 9. That one works. That gives me 6. So we can split it up into the square root of 9 times the square root of 6. The square root of 9 is 3. So we have 4 times 3 times the square root of 6. That's 12 times the square root of 6. So 12. And then the square root button is down here at the bottom, kind of over on the right. Square root of 6. Square root of 2 over 3. That simplifies first into the square root of 2 over the square root of 3. But if you type in the square root of 2 over the square root of 3, it's going to count your answer as wrong. If you type in the square root of 2/3, it's going to count your answer as wrong. Sorry, I may have lost my train of thought. That happens when a principal calls your room. All right, we can't have a radical on the bottom. So we need to multiply by that radical that's on the bottom. Multiply the top and the bottom by that radical. On the top, these are both under a radical, so we can multiply those together to get the square root of 6. On the bottom, the square root of 3 times the square root of 3 is the square root of 9, which is 3. Anytime you have a pair of the same square roots, the square roots cancel each other out. So on this one, I would recommend that you do the fraction button first to get the top and the bottom. And then on the top, do the square root of 6, and then click to the bottom and put in your 3. Let's see if I can get one more done on this video. The square root of negative 63. Anytime you have a negative under the radical, you're going to split this 3 ways. You got a -1 and then split up 63 using your perfect squares. So half of 63 is 31. So 25 would be the closest perfect square. 63 divided by 25 is not going to work. 63 divided by 16 I don't think is going to work. That's a decimal. 63 divided by 9 is 7. So it splits up into 9 and 7. The square root of -1 is I. The square root of 9 is 3. The square root of 7 we can't simplify anymore. The correct way to write this is 3i times the square root of 7. And the order that you write that is going to be important because it will count it wrong. I don't know if this review is counting it wrong, but on the test, I'm probably going to change it tonight, honestly. To make sure that it's counting it wrong. If you write I3 square root of 7, it should count it wrong. It needs to be written as 3i times the square root of 7. All right, that's it for this first video. The next video will go through adding and subtracting complex numbers, multiplying complex numbers, the discriminant, and probably the word problem with the toy rocket. We'll see how much I can get in that second video.